Hello, this is our pre-cal trig lesson 304 recording. Here, I got this thing in my way here. Let me move that. Okay. The objectives of this lesson is to identify key characteristics of the graph of a polynomial function using algebraic and graphical approaches, and to identify the relation between the graphs of a function and its derivatives. And that derivatives play comes in when they're introducing you to how it's going to look in calculus. All right, now to cover some of our vocabulary here. Some of it's new to you, some of it's not. Move my toolbar over. It says the smallest or most negative value of a function takes on over a specific interval. It's kind of a tongue twister there. I think I may have clicked twice. Okay, whew. I thought that is not the first vocabulary word. Okay. A point at which the graph touches or crosses the x-axis, and we know that is the x-intercept. And then a point at which the graph touches or crosses the y-axis is going to be your y-intercept. And a value or a variable that makes a function equal 0, that's going to be a 0. And then a count of the number of times a specific value occurs as a root of a polynomial function, that's going to be multiplicity. And then the largest value a function takes on over a specific interval is the local maximum. Now I'm on this page. The smallest or most negative value a function takes over a specific interval is going to be your local minimum. And then a point at which the graph's concavity changes is going to be your inflection point. And a description of the direction of a graph's curve, that's concavity. And then the smallest or most negative value a function takes over a specific interval. And notice that definition is the same as the first one, but we're going to call it a relative minimum. And as we get into the lesson, we'll understand why. And then the largest value a function takes over a specific interval is your relative maximum. Now, the right and left sides, and I'm talking about in behavior. Remember, I gave y'all a graphic organizer, I think lesson 301 or 302, that goes through and shows you different in behaviors and what they mean and how to write them out. So if the right and left sides have the same behavior, both went up or both went down, what is true of the degree of each of these polynomials? And that answer I can get my pen to work here, is going to be even. And then when the right and left sides have opposite behaviors, one goes up when the other goes down, what's true of that? And that's odd. And if you'll look at these graphs I have pictured here, this is actually a even, because we've got both sides, left and right, are pointed up. And then if you look at the one in here on the bottom, your right side's going up while your left side's going down. So they're having opposite behaviors. So that makes it odd. Now, if the leading coefficient of a polynomial function is positive, the graph will go up. And I was sitting here looking for my pen and couldn't find it. And if the leading coefficient of a polynomial function is negative, the graph will point down on the right side. So let's get in and use this information that we've gathered so far, and let's start by finding intercepts. Now, remember, I told you in lesson 303 that if you're rusty on your factoring, you need to get those skills sharpened by checking out different things on the internet. I highly suggest Khan Academy. I just think he's the best. So on this one, you know that your your y-intercepts are found by evaluating f of x where x is 0. So let's do this. And that's just going to equal 0. Since we don't have a constant, so that means our y-intercept is at the origin on the graph. Okay, now to find our x-intercepts, you have to find those by factoring, or if you can't get it factored, then you need to use your rational root theorem and synthetic division. Now, this is a fairly easy one to factor. So what I'm going to do is take out a negative x, because you see both terms have x's in them. That's going to leave me with a positive x squared minus 4. And now that x squared minus 4, if we remember back to our factoring, is a difference of squares. So that's pretty easy to factor. We don't have to really do any, only math thinking we got to do is what's the square root of x squared, what's the square root of 4. Okay, and now to find the x-intercepts, we're going to solve all of that for 0. So first, I have the negative x equals 0. You're just going to divide both sides by -1 to get rid, or multiply the whole thing by -1. Either way works. So that leaves me with x equals 0. So there's one of my x-intercepts. I'm going to write those down over here. X-intercept. So far I've got one at the origin, which we already knew that by the y-intercept. Now I'm going to solve this. Set it equal to 0. Add 2 to both sides. I end up with x equals 2. Do the same thing with this last one. X plus 2 equals 0. Subtract 2 from both sides. So those are my x and y intercepts. I should have just drew a box. But anyway, that's what your answer needs to be. And, you know, I'm always asking you to show your work. And everything I wrote up there is showing your work. All right, let's try another one. And this one's just almost the same as the last one, just different numbers. First, to find my y-intercept, I'm going to evaluate for when x equals 0. And then that equals 0. So again, my y-intercept is going to be at my origin. And then I'm going to factor out an x. And then again, no, that is not the right answer. I was factoring out an x, and I was thinking ahead of myself, and y'all will see why I was thinking ahead of myself in just a second. Okay, now I factored out the x. So here again, I've got a difference of squares. X squared is x. 25, or not x squared, the square root of x squared is x. Square root of 25 is 5. Now y'all can see where I was coming from. I was just getting ahead of myself. This first one, x equals 0. So we know we've still got that x-intercept at the origin. Then I'm going to say x minus 5 equals 0. Add 5 to both sides. And then x plus 5 equals 0. and I'm going to subtract 5 from both sides. Now let's be smart, and I'll just put a box around those. So there's my, I just thought I was going to be smart. My mouse is acting all jumpy today. There we go. So that's what our answer would be. All right, here we're going to describe the end behavior by writing a limit expression. And in your lesson, well, hold on. First, I'm going to look at this, and I'm going to determine what the end behavior is. So here I've got a little graph. That's all that is. My degree is odd. I'm not drawing a very good arrow. Okay, my degree is odd right there, and my coefficient is positive. So if you look at that graphic organizer, it's going to tell you if it's odd and your coefficient is positive, your right side's going to be going up to infinity, your left side's going to be going down. So when we write that out, we say, I want to make sure I write this correctly, as x approaches positive infinity, f of x approaches positive infinity. But the way they're telling you to write it, write with a limit expression, this is what it looks like. I'm going to write LIM, that's for limit, and then under that I'm going to say x approaches positive infinity, and then right beside the LIM I'm going to write f of x approaches positive infinity. And all that is just less writing, and it makes your answer more compact. So also by looking at our graph, we say as x approaches, this is for the left side. Matter of fact, let me put right side, left side. And as x, excuse me, as x is approaching negative infinity, f of x is also approaching negative infinity. And the way I'm going to write this is limit there we go. And so that right there is what my answer is going to be. On this one, there really is no showing your work. I mean, you can draw the little stuff like I did out here. You do not have to write as x approaches and all that stuff. All you've got to write is what I've put in the box. Okay, on this one, we're going to use the graph to state zeros and the multiplicity of roots. And when you look at this, you think, oh, well, this is easy. I can see my intercepts right here. And I can see my other x-intercept right here. So it's 0 and 2. But there's a catch. One of these, it actually has more than one intercept. Now we have to determine, is it 0 or is it the 2? So the way we're going to do this is, well, I'm looking at the wrong problem. No, I wasn't. I was looking at the correct problem. I'm going to have to factor out or factor this. That's going to help me find the x's. So on this one, I'm just going to leave that negative, and I'm going to factor out x squared. Oh, wait, I said that backwards. I'm going to leave the negative. I'm not going to factor it out. So that's going to leave me with a negative x plus 2. Now, when you set these equal to 0, I'm going to have x squared equals 0. So that tells me right there that when, well, you got to take square root of both sides. We're still going to do it the same way. So we have x equals 0. Square root of 0 is 0. But remember, it's plus or minus 0. Okay, there's your trick. So that means that, how do I want to write? Zeros at origin, oops, multiplicity of 2. And then I've got to solve my other factor. I got negative x plus 2 equals 0. Subtract 2 from both sides. And then you can multiply or divide everything by negative 1. It doesn't matter which step you take. So I got x equals 0. I mean, x equals 2. So that means I also have a 0 at x equals 2. And there's no multiplicity there. And that's all you've got to do. You're going to have to factor, find out, you know, if you've got square root stuff going on, things like that. So that way you can find out how many times is it actually crossing the x-axis at that point. Okay, on this next one, it says identify extrema and classify as a relative or an absolute max or min value. Now, there again, you've got to know your end behavior, kind of what it's going to look like. And this is the easiest. Okay, let me put this right. This is the easiest to work on a calculator and know how to use it. So let me, you know what, since I'm not recording this actually in the room, I can do this way. And let me turn everything off so that way y'all can see what's going on the screen. So let me go to y equals. I think this is the problem. Yes, it is. I've already got it keyed in there. So I'm going to go to graph. Seeing that highest degree was 4x cubed, so we already knew what our end behavior was going to look like. So what you do is you key it into y1, you push graph, kind of get a feel for it. You can go over here and change your window if you need to so you can see it better. I'm going to go back to graph. Now, in this you may remember from Algebra 1 or Algebra 2, we're going to push second trace, and if you see number 3 is minimum, number 4 is maximum. So let's find our maximum first. And you see my little cursor, it's moving. So what it's, right here it says left bound, it's asking for what my left side is of my curve. And I'm saying, there it is. Then I'm going to move over here to the right and hit enter. And then it asks for a guess. I just put it at the top. And look there, when, that's crazy that I have an x value this time. But you always answer in terms of y. So this is, my maximum is going to be at y equals 15. So the way that you're going to write this, I've lost my pen, there it is. Local max at 15. That's all you've got to put. And then we're also going to do this to find our local minimum. And since our end behavior looks like this, and we know it's going to infinity, there is no absolute or relative max and min. They're only going to be local. So let's go back to the calculator right quick. Now I'm going to go to find my minimum. So I'm going to go second trace, number 3 for minimum. Oh, this happened to me earlier. Let me do it again. Second trace. I get trigger happy. Okay, so I'm going to tell it this is my left side. This is my right side. And there you go. So my local minimum is going to be at -1. Like I said, you always answer in terms of y. And I'll put that on here. Always answer in terms of y. Okay, now we're going to sketch. We're going to take all this information that we've just discussed, and we're going to throw it in a graph. This is like everything coming together. And so I'm going to graph this, and I look at it, and I say, okay, my coefficient is negative. My degree is odd. So my end behavior is going to look like this. Because remember, if it's negative, my right side's going to point down. All right, so I know what my end behavior is. And the first thing I'm going to do is I'm going to find my y-intercepts. Actually, I'm going to come over here and make me some points. I don't know if I'll actually need that many, but I'd rather have too many than not enough. Oops. I'm just going to move those up here out of my way. Okay, I already know what my y-intercept is. You could go in there and replace all your x's with zeros, but we've all become really familiar with the fact that that constant is going to be our y-intercept. Let me move my toolbars back over. So I'm going to go ahead and grab one of my points. And notice that the y-axis, they've put it in 2's. So -3 is going to be right there in that middle. So I already know where one of my points is. The next thing I do is I'm going to make me up a table of inputs and outputs. And usually when I do this, I always start with -3, then I do -2, -1, 0, 1, 2, and 3. I've already keyed all this into my calculator and figured out the answers, but I want to show y'all a quick trick for doing this and doing it fast. You may already know this little trick. Let me see if I've already got it in here. If I push the second key and the enter key, it puts in my problem that I'm working with. You know what? And I don't want to do that. I think it is the correct problem, but I'm not positive. So let me key this in, -4, and I'm going to replace the x with a -3. And that's cubed. Then plus 15. I'm going to replace that x with -3. And that's squared. Then I'm going to say -8. Replace that x with a -3. And that's linear, so I don't do anything with it. And then I say -3, and I hit enter. And I get 264. So let me write that down. Now, it takes a while to key all that in, especially when you're on the computer. But I'm going to push second enter. That's going to throw that problem back out there. See how it's still got the -3s? I'm just going to use my arrow and change all those 3s to a 2. Push enter. And then I've got my next number is 105. So that's a neat little trick that you can use on your calculator to get things in there really fast. But to save time right now, I'm just going to, that's 24. It's not a very clean 2. And then we already know that the y-intercept is at -3. And then when I key in a 1, I get 0. And when I key in 2, I get 9. And when I key in 3 for x, I get 0. So what I'm going to do now is grab those points and I'm going to plot them. Of course, I can't plot -3 and 264 or -2 and 105. They're too high. But let me plot these others that I know. I'm going to start at the bottom where x is 3 and y is 0. And so we know that that's one of our y-intercepts. And then where x is 2, y is 9. So that's going to be in the middle here. And then where x is 1, y is 0. So there's another intercept. And then I'm just going to kind of give myself an idea. We've already plotted the y-intercept. So for -1 and 24, I'm going to move these dots out of the way. I'm just going to eyeball it. You know, I know that there's no way that that's 24, but that lets me know how my graph is going. So you can look at this and you can tell already that my end behavior, look down in the bottom right corner. Well, I thought I had my pointer. Here's my end behavior. Okay? And then it's coming down right here, and then it's shooting back up to there. So I know I've got another y-intercept somewhere between 0 and -1. And I've got to determine what that one is. And I just do not graph very well. But let's see if I can get us started. And I just graph it in pieces. And that's already, that pop-up kind of scared me. So let me try this again. So my end behavior is going down, and that's probably good enough. And then I know this is going to curve right here. And I know this is going to curve down here. Like I said, I just don't graph very well. It's not as smooth as it should be. And I know that my intercept is going to be somewhere between 0 and -1. So I'm not going to cross that yet. Oh, there it is. Okay, so I'm going to come back over here. Now, this is where I have to use that rational zero. And remember, I'm going to find out the factors of my constant, and I'm going to abbreviate that. And then I'm going to find the factors of my coefficient. I'm abbreviating that too. I always put my constants above, so that way I remember they go in the numerator, and my coefficients go in the denominator, so I left them on bottom. So my factors for negative, or for 3 are plus or minus 1, plus or minus 3. My factors for 4, plus minus 1, plus minus 2, plus minus 4. And then the other ones that I can come up with are, I can do 1 over 1, which is 1, so I'm not going to do that, and 1 over 2, and I can do 1 over 4, and then I can do 3 over 2, and I can do 3 over 4. Okay, so I know that number 1, it's going to be negative, and I also know which fractions it could be. Let me change. Okay, it's negative, and I know that it's between 0 and negative 1, so 1 divided by 2 is 0.5, that's between. 1 divided by 4 is 0.25, that's between. Now, 3/2 is not between, so I know that's not one of my choices. So what I'm doing right now is I'm cutting down how much work I got to do, okay? That's exactly what I'm doing. And we know that 3/4 is 0.75. So I'm going to start with the half, and then I'm going to do the quarter, and then I'm going to do the 3/4. And this is where that synthetic division comes back into play again. So I'm going to start out, and I'm going to use decimals because they're nice, pretty decimals. In other words, they're terminating. And then I have -4, 15, -8. Oh, and make that a -0.5. Woo, I almost forgot. -3. Remember, you're always going to bring that first coefficient down. So, and it's nice to go ahead and use your calculator, even if you can do this in your head, because it keeps your signs accurate. So I'm going to say, in my calculator, I'm going to say -0.5 multiplied by -4. That's going to give me a 2. I'm going to add that down to 17. Then I'm going to multiply 17 by -0.5. That gives me a -8.5. There's a decimal there. It won't show up. Then I'm going to subtract 8 from that. I get -16.5, and then I multiply that by -0.5. That gives me 8.25 minus 3 gives me 5.25, or 5 1/4, 5.25, however you want to write that out. So I know that since I have a remainder there, I know that 0.5 is not my 0. So that's gone. So now I'm going to do the quarter. And there again, I'm just going to use 0.25 because it's a terminating decimal. Okay, wrote all of my coefficients and my constant down. Bringing down that -4. Oh, don't forget to make that 0.25 a negative, because we know that it's on the negative side of the axis, or x-axis. So I'm having -0.25 multiplied by -4. That gives me a 1, which gives me 16. So I'll multiply 16 times negative 0.25. That gives me a negative 4, which gives me a negative 12 when I add it down. So negative 12 times negative 0.25 is going to give me a positive 3, which gives me a remainder of 0. So, ta-da! I found my other x-intercept. So I'm going to grab one of these points. I'm going to put it about right there. That almost looks like a half. I can't remember which thickness I had that on. But let's try. If I was doing this on paper, well, I didn't quite cross it, but y'all know what I'm doing. There we go. If I was doing it on paper, I'd actually turn the paper sideways and write on it that way. But I can't do that with my pad. So that's how you sketch the graph. You see how we were pulling together everything we learned, doing the intercepts, using the rational zero theorem. We were using the factoring theorem. We were using synthetic division. I mean, everything. We were pulling it together. Okay, so the wrap up here, of course, you can't save the whiteboard, but I've sent you notes that you could have been filling out while you were watching this. Please work on those practice problems. I've already got people from 303 asking me questions that if they had worked the practice problems, they would know. But complete your assignment, complete the quiz for 304, and please attend your small group sessions this week if you're able. It is a requirement, but I know some people have full-time jobs and such that they have to watch the recordings later. But all right, thank you for listening.